Good evening and welcome to the February 17th meeting of the Pinal Geology and Mineral Museum and the Pinal Gem and Mineral Society in Pinal County, Arizona. Tonight we're going to talk about Mars, but I want to get a little business taken care of first, just a little bit. We will have a March meeting, and the March meeting is expected to be St. Patrick's Day in exactly 1 month, March 17th, 2001, and same place, same channel, different video URL. So check our channel and we'll do that. The program is to be announced, but I think it's going to be close to home. All right. This is, let's see what else is going on today. Getting ready to do this, and oh dear, being your own tech is fun. I will. There it is. We're going to talk about that. But what else have I got for you? Ray is working at the museum periodically, and if you have Ray Grant, our director and curator, if you have an interest in volunteering, please do catch up with him. You can use the email sent at the bottom of the screen. That actually comes to me, but I forward it to Ray if you want to contact him. And you can also call the phone number. The Chamber of Commerce adds it. That phone number is on the website, which is, I hope, there you go, pinalgeologymuseum.org. And the email is pinalgeologymuseum@gmail.com. All right. We are expecting, we're hoping to reopen to the public in September. That's our usual reopen after the summer. But we hope to, I'll try not to lean anymore. My microphone is on that side. So, but I'll try and be here. We're going to try and reopen for a grand reopening and our delayed show. There will be no show in March like we usually have, but we hope to have it in September. Our tentative date is the Saturday of Labor Day weekend. I picked that. Nobody else had anything to do with it. I picked it because it was on the calendar. So if we don't make that date, I apologize, but I had to pick something so I could change the event on Facebook. So I picked that. Hopefully something else. So hopefully we can do it then, or we will soon pick another date as soon as conditions allow, of course. Also, let's see, there was one other thing, and I can't remember it right now, so maybe you'll get it at the end. But please like and subscribe if you're watching this video afterwards. Welcome to the video of the meeting. And please consider liking and subscribing. Visit our website at pinalgeologymuseum.com. And there's all sorts of fun stuff about Pinal County, Arizona geology, and world geology. Also, you can find us on Facebook and Twitter and Instagram and all sorts of places. So please look us up. Okay. That was the other thing. You can ask questions if you're logged into YouTube. Please feel free to make a comment and ask a question during the program. I will do my best to answer them. Please understand that I might not be able to, but I will try and find an answer. And if I can't answer it live now, I will do my best to get an answer for you. So please check that out. All right, I'm going to go ahead and start the program. And yes, it's live. It's A Brief History of Mars. I'm Bob Hole. And what do you know? Here we are. I'm going to start. Mars has been a fascination, an interest for a lot of people all around the world for a long time. And it has spawned a sort of mini industry in publishing in the last 150 years. These are some of the titles. All but two of those are science fiction. The left-hand side, How to Live on Mars and Packing for Mars, are nonfiction, and they're around too. The timeline of Mars exploration, and I'm not going to cover all of it tonight, but by 2000, before the Common Era, BCE, Egypt had noted Mars. It had noted its place in the sky and its funny movement in the sky. It sometimes moved forward or backwards in all sorts of strange places. China had recorded it also by 1050 BCE, and the Babylonians certainly had the information that we're watching Mars by 650 BCE. First telescope was turned toward Mars in 1610, and the first map is 1840. We're going to pick up where that gap, where the gap ends. So, pre-space age, people could just observe Mars. Beginning of the real exploration of Mars. In 1608, the first telescope was probably invented by Hans Percy. Percy was a Dutch lens maker, and there are several other claims by people who have also said there were several other claims by people on behalf of other people who were working with lenses and working with tubes and may have actually invented the telescope. But Percy gets the credit partly because he published some notes, and Galileo got hold of those notes, and he built his first telescope in 1609, and he did them from Percy's notes. There were no diagrams, so who knows what Percy's scope actually looked like, but probably something like the one on the right there from that Galileo built. That's one of his early ones. It's not his first. But he waited until 1610 to actually turn the telescope to Mars. And that's when the real exploration of Mars could begin in 1610. Just before that, though, while Galileo was building his telescope, Johannes Kepler was mapping Mars, at least the motions of Mars, mapping the motions of Mars. And it was actually Kepler who, well, let me back up just a little teeny bit. Copernicus, if you remember, brought the idea of a sun-centered solar system instead of a Earth-centered solar system to the fore. And Copernicus, some people after Copernicus said, yeah, okay, the Earth and Venus and Mars goes around the sun, but we think everything else goes around the Earth. And Kepler kept careful notes, made this chart. There are similar charts today. This is the position of Mars in the sky. And the center of that is the Earth, and he looked at that, and it goes forward and backwards. And if it goes forward and backwards and retrograde and positive grade, Kepler reasoned and mathematically figured out that it could not be orbiting the Earth, because no planet would be silly enough mathematically to go in try and go in the circle around the Earth and do all those coming forwards and going backs and going backwards and all the loop-de-loops it was doing in the sky. And he determined that at least Mars was also going around the sun, just by that little chart, his math. In 1645, Johannes Helios first noted the phase of Mars, and that phase is like the moon phase, waxing, waning, half moon. That was the first time that anybody had seen that on Mars. They had seen it on Venus and Mercury, which is why they believed that Mercury and Venus went around the sun instead of the Earth. This confirmed Kepler's findings and did show that Mars orbited the sun rather than orbiting the Earth. We skip ahead just a little bit, but William Herschel, famous early British astronomer, began his observations of Mars in 1777. And he was able to see, using his telescope, he was able to see that Mars did have an atmosphere. He could see just along the edge, a little fuzzy bit, and that was the atmosphere of Mars. And he measured it and came to the conclusion that Mars does have a considerable atmosphere, but not as big as Earth, he thought, because he knew roughly what Earth, or they had an idea of how thick Earth's atmosphere was, and Mars's was not as thick. So it's a considerable but moderate atmosphere. And so he believed that the Martians, the inhabitants of Mars, had a nice life like ourselves. Now, after Herschel, people began to start to have telescopes that were good enough that they could start to map Mars. This is the late 19th century Atlas of Mars, one of the first very detailed atlases of Mars. But Johann Heinrich von Mädler and Wilhelm Beer, German astronomers, were the first to map Mars, as far as I can tell. They produced their first globe in 1830. It's easier to make a globe of a distant body like that because you can take around, you assume Mars is roughly round, you take a sphere and you draw on it like you see on Mars, and it shows up. It took them a while to do that, and then they were working on other things too, like the moon, and they produced their first flat map of Mars in 1840. Had to do a lot of math and cutting up. You saw the cut up map of the atlas. They were also, as I said, they were working on the moon as well, and they produced very detailed maps of the moon that people were using into the 1950s, at least as a base, and they would check back and forth, and they were very good maps of the moon. Not so good to Mars. This is what they could see. Mars is, of course, a little farther away, but this is what they could see. Light places and dark places. They didn't try to name anything. They just put letters on the different things, the different features that they saw, the black spots, and just left it like that because that's all they could see. They tried, and they did a good job. They actually did do a pretty good job. William Rudder Dawes, also an English astronomer like Herschel, he made extensive drawings of Mars. He studied Mars for a while, and he made at least 27 really good detailed drawings of Mars. He did not make a map himself, though. He just made the drawings. Richard Proctor, living about the same time, used spectrography, and the spectrograph of Mars supported, he believed, the presence of oceans on Mars. That's not actually what's there, but subsequent work has figured out that there's not any water on the surface of Mars. Well, not much, but at least that he thought there was. And so he did his map using the drawings of Dawes, those 27 drawings that Dawes had done, and published his map in 1874. This map was produced in 1867, but it was not published until 74. He called the dark places seas because he thought there was water there. And that's the first use of this terminology that we had seas on Mars, the first idea that we had actual oceans on Mars. And some of His, he names Herschel's continent and Dawes continent and several other things. None of those names survive, to the best of my knowledge. I don't know every place on Mars, but I don't believe any of those places names still exist. Bill Flamarian is important to this story, more important than anybody before him, except the first mappers. He was a French astronomer, a science fiction writer. He used the name Camille Flammarion. His first name was Nicholas, though. Nobody else acknowledges that, apparently, except Wikipedia. He was a science fiction writer, starting his science fiction writing in 1858. Never wrote a science fiction book about Mars. He wrote many popular books on science, though. He was an astronomer, and he did serious astronomy work. And he was looking at Mars, and in 1873, he thought that, and this is his science, this is not his science fiction, he thought the red color of Mars was because of the plants on the planet and the changes of the plants. He began to think the seasonal changes of the plants were partly responsible, at least, for the different changes that we see on Mars as when you look through a telescope. At least the kind of telescope he had. This is his book in 1892, The Planet Mars, and it was very influential on future astronomers. This is his map that he created in 1876. If you are able to see, his dark spaces are still oceans and seas. The light spaces are still land that he considered. You'll see no straight lines, except on the grid. And so he was not seeing straight lines in his map in 1876. 1884, he made a more detailed map, this one in color, and showed his dark and light spots. Most of the Mars maps, because they were made through telescopes, like this one, they drew things as they were to be seen through telescopes, and they didn't flip the image. So the South Pole is at the top. South Pole is at the top of this map. Excuse me. Flammarian's map of 1876 versus 1884, just to show you he was consistent through that time. And the Newton C is on both places. That might get you oriented. One's a flat map too, and one's circles, so he's working in different scales. But there is that. Also, I want you, if you would please, to note that big dark spot with a ring around it on the left-hand globe, and you'll see that again another time. This is Giovanni Schiaparelli, excuse me. He worked a little bit later than Flammarian. He's an Italian astronomer, and he was the first to see the canals, the canali. The canali, he saw them in 1877, reported seeing them in 1877. And he is, if you've ever heard of the Martian canals, he's the one that started that with the word canale, which is Italian, of course, for channel. This is his book of 1893. This is a second one that I will refer to again in a moment. It was an important point. The English version was an important point in Mars history. This is Schiaparelli's map, and it has the same dark spots. If you look to the left there, at the left, near the left edge, a big spot, big dark spot with a ring around it. And that will come around again. You'll also note that his names did start sticking around. The big thing that looks like a crack in the egg just above the box near the bottom right center is Hellas, also Greece. He thought that was a Good name for that. And the white spot to the left of that, the first white spot, is Argyle. And Argyle is also a name, and several other of these are names of places still used on the planet Mars. And still in Schiaparelli's map, the dark areas are interpreted as seas and channels. Look at all the straight lines. Those are the canali, and they are hopefully visible to you. And this time I flipped the map upside down. The South Pole is mostly seas, or the Southern Hemisphere is mostly sea, and the Northern Hemisphere is mostly land, according to Schiaparelli. And this is the problem with canali. It means both in Italian, canal and channel. Schiaparelli meant channel. And if you look at that, that's a river channel. It's a natural channel. It does not, a intelligence-made canal. A canal, it means it has been constructed. A channel is not necessarily constructed. Percival Lowell read English, was an American amateur astronomer initially, and he read both Flamarian's and Schiaparelli's books in about 1892. Excuse me, I apologize. He read both of their books in about 1892, and he took the vegetation information from Flamarian, and he took the canali information from Schiaparelli, and he came up with a huge desire to study Mars. So, being a rich man, he traveled from Japan, where he read the books, to Arizona, and using family money, built an observatory here in Arizona at Flagstaff. It was built primarily to observe Mars, and it was the first observatory with a location chosen for its atmospheric visibility. All observatories before that time were picked because they were near a college or easy to get to from a city or in the middle of a city. Several of the oldest observatories are smack dab in the middle of places like Rome, Milan, Paris. This one was picked because it was at high altitude, so there was less atmosphere, and because Flagstaff has, I am told, Flagstaff, at least at that time, had fairly steady weather, fewer high wind times around the year, and it was a bit remote. So it was away from what even then was the light pollution of cities. And he built that in 1894, and it was the first observatory ever built because of the atmospheric conditions. It is now 120, going on 122 years or 27 years old. Note the address. It is on Mars Hill. That's it. That's Percival Lowell picking Mars Hill to put his. He named Mars Hill because that's where he put his observatory. And this is Percival Lowell's first book on Mars. It was published in 1895, and in it he started to talk about channels, canali, as canals. And he talked about canals, and he described them and said some interesting things about them. He wrote a second book in 1906 talking about Mars and its canals, and went more extensively into the description of the canals as he saw them. He reported over his time looking at it 183 canals. He could find all of Schiaparelli's except 12 Schiaparelli had seen 79, so Lowell had seen all but 12 of those 79. And Lowell explained in the first Mars book that he believed they were real because they had been seen by several people. 20 astronomers around the world at that time had seen the canals. None of the other astronomers around the world could see them, but he could see Schiaparelli's. Other people saw them too, so he believed they were real. He also believed they were real because they stayed in one place so they could be found, and they stayed the same width, and they stayed the same length, and they all did that. And he also believed they were real because they sometimes disappeared and he couldn't find them. Interesting logic, but he believed they were obscured by cloud or other disturbance at different times, but they reappeared in the same place. That was why he believed that they were real, because they disappeared and reappeared. And he knew full well that a simple little straight ditch is not going to be able to be seen across the planetary distance. What he was able to do, what he suggested, though, was what they were seeing, what he was seeing, and the others that were seeing the canals was seeing, was the agricultural belt that lined the canals. He thought that the Martian surface was desert, and that those canals were bringing water from the North Pole down into the desert, and they were lined with agricultural belts, as you can see in this picture of the Nile from orbit of the Earth. And so he wasn't actually seeing the line of water. He was seeing the line of all these wide belts of agricultural lands. That's the Suez Canal there in the same picture in the red box. And as you can see, it's barely visible. It is a constructed canal. And there is a line visible, but most of that line is the built-up area and the agricultural area around the Suez Canal. So his logic holds for both the Nile and for the Suez Canal here, but the Suez Canal doesn't have as much agriculture area, of course, as the Nile. These are some of his drawings that he created or made in 1894 and published them. These show the canals. These are all, the south is up on these. And so the canals he brought for bottom, he saw them in these figures merging with each other or meeting with each other and going parallel. And he believed they all brought water down from the North Pole to the desert. And these were made starting on November 5th of 1894. I like that date, my birthday. All right, Percival also made this full map in 1896 of Mars. He did it conclusively, included all these rings. Where, if you note on the right side, there is that broken circle with the dark center, and that large circle on the far right, that is Hellas there. He picked a different meridian for the ends of his map than some of the other mappers. He also published the first photographs. Now, if you look it up, I'll tell you in a minute, somebody else is gets credit for the first photographs of Mars. These are the first photographs of Mars. They were published in 1907. And if you look at the type at the bottom, that's as big as he could make those pictures. All those little tiny circles are the maximum that he felt that you could see anything with his negatives. The large circle on the right is one of his drawings, and the smaller circles on the right side are the best images that he could come up with. He picked a few and published those as little blow-ups of the photographs that he made. They were all negligibly sized. He did believe the lighter colored hemisphere was flat, with the mountains worn down from age. And again, because it was flat and there were no mountains, so there were no river channels, he believed that the canals were there because of that, as well as the fact that it was desert. Kurt Laswitz wrote the first known science fiction book about Mars, and he relied for his science on Schiaparelli and Lowell. It was published in 1897, shortly after Lowell's first book, and it was published in Germany. An English translation was not published until 1971, but interestingly enough, just as a little sidebar, because I know there's some of my science fiction friends watching this, this book was read in Germany, or in Luxembourg, in German, by a young gentleman named Hugo Gernsback, who moved to the United States and co-founded science fiction as we now know it, because he was so turned on by this book, among other things. War of the Worlds, published in 1898. You may remember this book, or at least the title, if you haven't either read the book or seen either of the movies, any of the movies. But he relied on his science on Lowell, even though none of it occurs on Mars. All of the novel takes place in England, but he relied on that idea that the northern hemisphere was old and worn down from Lowell. Didn't need the canals, but he thought about that, the old and worn down plains. When he started his book, Mars must be, if the Nebular Hypothesis has any truth, older than our world. The Nebular Hypothesis is the one that's still in play today. It's the idea that the planets formed from a gas cloud that was circling the sun. And Wells's idea was, and is probably a little bit true, that the outer planets formed first. Logical idea, whether it's true or not. The planets formed first. Well, I can't say Pluto anymore, can I? But the outer planets formed first, then Jupiter, then Mars, then Earth, then Venus, then Mercury. Probably not quite accurate, but if that were accurate, then Mars has to be older than Earth. In 1912, Edgar Rice Burroughs wrote the first of his Mars book. This became a long series, and it's been made into movies a couple of times, and it's the first American science fiction novel about Mars. And he used Lowell and the canals and the old surface as part of his plot for canal visiting, or Martians living along the canals in the desert on an old world. Science. Joseph Evans and Edward Mulder, I couldn't find a picture of Evans, in 1903 conducted some experiments. And Evans was a teacher, and he and Mulder got together, and they conducted these experiments with Evans' students. And what they did was they held up a disc similar to this one, and they got their students to draw it. And toward the back of the room, the students were drawing things kind of like this without the dots. Because at a distance, especially if you're nearsighted like me, then the dots merge, and what you get is just the lines. So with these experiments in 1903, before the 1907 Mars and Its Canals book, they determined that the canals were probably not real, that they were maybe a line of volcanoes or a line of craters, of asteroid craters, meteorite craters, and were not actually the canals. Eugene Antionati, he published the first good telescope photographs in 1909, shortly after Lowell's second book on the canals. And his 1909 images were much better, and he didn't see any canals. Again, these are telescopic images. He saw lines, he saw things. Again, the South Pole is at the top. South Pole is at the top. But these are his images. They are much clearer and much larger, better, I'm not sure, better telescope or better film, but he got some actual real images of Mars, and there were no canals. Now, most of the scientific world believed there was no canals. Lowell, into the 20s, at the time of his death, still believed they were canals. This is Antionati's map, published in 1929. You can see all the swirls and waves and things. There are no straight lines on there, no canals. Now we're going to get into the space age. Now we got real pictures, okay? This is a NASA Hubble image of Mars, and we're going to go to Mars. These are the Mars missions since 1960. You don't need to look at the bottom. 1960s on the left, 2020s on the right. The thing I'd like you to notice is just the color. The failures are in orangish. The successful missions to Mars, this includes landers and orbiters and rovers, excuse me. This is and the successes and the failures. The failure rate was much larger in the early days until about 2001. You can see that using this. This will make it a little bit clearer. The failure rate has gone way down over time. The success rate is pretty steady, but we've gone up since that dismal beginning and since 2001, especially. And that gray line there at the bottom those are the operational missions on Mars. The earliest still in operation is from 2001. That's an orbiter. And in 2018 is the last on Mars that is operational until last week. I didn't include in this, sorry. But there's the lines without the graph. The successes started in 1964. The missions started in 1960. And then the operational ones are still in operation since 2001. We're still failing them. And this is just another way to pinpoint that of the two missions launched in 2001, one is still operational and the other was a success also. Some idea of the number of launches per decade, 1960s on the left, 2020s on the far right. 2020s, there are 3 more planned for this decade. Remember, it's only 2021, excuse me. We had a lull in the 1980s, but we're going better. There have been 49 total. Tomorrow makes 50. No, these are launches. Excuse me. Tomorrow doesn't make 50. But these are the total launches. Next year, I think, is when we get next. We'll find out when I'm reminded by this slide. Mariner 4 is the first successful mission that included Mars. It was a flyby mission, and it flew by in July of 1965, and it was not even an orbiter. They just aimed it sort of in that direction, and it was only had one stop, and that was Mars. It is still out there. It stopped transmitting, but it is still out there, but it's orbiting the sun, not Mars. Total mission data for all it did in 1964, total mission data was 5.2 million bits, or 0.65 megabytes. Now, I had a digital watch 20 years ago that had 2 megabytes of memory. And so this was an early one. And remember, we went to Apollo, or went to the moon in the Apollo program with computers that could today be dwarfed by our phones. So we're doing we did a lot with this little bit of data, and we're still analyzing it. This is the first image from Mars. Now, this is a hand-colored, hand-drawn image. The NASA engineers put it together by printing out all the digital data, those little ones and zeros and whatever. I'm not sure what language they used, what number system, but they put all the ones and zeros together, and they got this as a color image by taking crayons and coloring each spot, each pixel on a sheet of paper. They did a pretty good job. This is the image at the bottom here. The far left image at the bottom here is the souped up photograph. And though it's not in color, they said color data, but they only printed it in black and white that I could find. It's probably around color somewhere. This was a pretty good image. You see the bright spot on the bottom of the planet. The rest is space. Those white things that are, those white blocks on the bottom right of those photographs are distortions in the data. And so they couldn't print them, but they got the data. They just didn't print them for some, I'm not sure why, but they're computer artifacts, and they should be black, like in the hand-drawn copy. All right, let's see. Oh, yeah, and this is the first close-up image of Mars that it was taken. That was taken a little bit the same day, and this is the actual photo. When another photo, I mistitled this. This is a different photo, but it is a photo of the Martian surface. This is another photo from that flyby. No canals. They took a lot of pictures like this. They did not see one canal. And this, in 1965, is the time when, for all scientists, the canals went away. Not until then. The next big mission to Mars was an orbiter that went into orbit in 1971. Mars 2, launched by the USSR. It was, they actually turned it off in 1972 because I don't know why. It was the Soviet Union. Who knows what they did, why. But it was an orbiter. It took some pictures. Had on board a descent module, including a rover. They sent a rover to Mars in 1971, 72, but the module crashed. The rover crashed, and the lander crashed. It was the first human impact on Mars. So they were there first. They were on the ground first. Unfortunately, they hit a little too fast, so it wasn't sending back any data. The Viking landers were sent up in 1976 or 75 for landing in 1976. It takes 9 months to a year-ish, depending on exactly how far away the planets are. And the launches are roughly every 2 years because of the orbits of the planets. Viking 1 and 2 shared a lander design. This is a model of the Viking Lander. And the first one, Viking 1, landed on July 20th, 1976. Very disappointed. It was the bicentennial year for the United States, and the U.S. really wanted it to land on July 4th. They just couldn't make that schedule. I'm not sure why, but they didn't. There was a lot going on July 4th of 1976. It landed on the Golden Plain, Chryse Planitia, in the northern hemisphere of Mars. And this is the first photo taken from the surface of Mars. This was taken about 90 seconds after the lander landed. You can see the foot on the right there. That's the foot of the lander. And the left hand is a little bit smeary because that's shifting dust during the time it took to take the exposure. And shortly thereafter, this is the first color image taken by Viking on the surface of Mars. And you can see it's a red planet. This was taken for the Viking orbiter. It stayed in orbit while Viking 1 was landing, and this is Olympus Mons. It's a shield volcano. It's the largest volcano in the solar system. And I like this picture because it shows the fossa, the trench around the volcano. It's a fault created as the volcano grows. It sinks into the surface because of the weight of the lava coming up and building up. It sinks into the surface. On Mars, this happens quite a lot. Many of the volcanoes have fossa, these trenches around them. If they happen on Earth, they're not as prominent, partly because we have vegetation and other things going on. They get worn away, but because they don't go boom, they take a little more time to form. Viking 2 was landed in September of 76. It landed in Utopia Planitia. And you may find this familiar. This is Viking 2's first image of Mars. It was also a foot selfie, as well as showing the rocks on it. They're a little bit different formation than the Viking 1 lander, which is why we know which was Viking 2 and which was Viking 1. This is not the color photo from the first color photo, but it is a color photo of frost on Mars. It was the first confirmation that frost could happen on Mars. And this is from May 18th, 1979, and again from Utopia Planitia. Pathfinder was another launch by the US. Pathfinder, this is the lander called Pathfinder, and it landed July 4th, finally, 1997 in Ares Valley. It was contacted in September of 1997 and has been renamed from Pathfinder to the Carl Sagan Memorial Station. This, if you look at the left side of the lander in the black and white photograph, this is what that is in the color photograph. These are the balloons that surrounded the lander when it fell on and landed on Mars. It was surrounded by these balloons. It was a weird landing system. It was cool. And basically it came in and hit the surface with all these balloons and bounced 15 meters on its first bounce back up into the air and bounced along until it stopped. It had a device would turn it over and do whatever it needed to do to get right side up before when the balloons deflated. It happened to land right side up. And that ramp there, this was the Rover ramp. It took a rover with it. The rover's name was Sojourner, and that picture is from Sojourner looking back at the Pathfinder lander. And there is Sojourner taken from Pathfinder lander. It also landed at the same time in the same place, and it is the first rover ever to operate on another planet. It operated for 84 days at least. We know at least because it communicated through Pathfinder, and the signal was lost in September from Pathfinder and Sojourner. We lost contact with Sojourner because we lost contact with Pathfinder. The last message to Sojourner was to drive around Pathfinder, and it may have done it, may still be doing it, who knows, probably not very long, but it was told to drive around the lander. And so it could have operated for longer. We probably will never know. It did travel before that command 330 feet, which is pretty long. And its last contact was the same day as Pathfinder. Mars Odyssey, this is the one that's still in operation. It is estimated to be in operation for at least another 3 years. It was put in orbit in 2001, and it is now 20 years old, and it'll be able to drink next year. Mars Express is also still in operation. It was launched by the European Space Agency, launched in 2002, in orbit since December 25, 2003, and they expect it to last until 2026. Spirit. You may remember Spirit if you've been watching Mars for at least 15 years. Spirit landed in 2004. It was a rover, had a twin rover with it that we'll talk about in just a moment. This is the first first color photo taken by Spirit of its landing space. More rocks. Yay, rocks. It quit working in 2009. It got stuck in soft sand, and they couldn't rocket free. So they kept contact with it, and they were getting pictures and things from data from where it was, but it was basically a rover turned into a lander because it got stuck in the sand. Don't get stuck in the sand. Arizona's full of sand and mud and rocks and things. Use a four-wheel drive. This didn't have a four-wheel drive. It had 6 wheels. Okay, this is Opportunity, the twin to Spirit. This is a selfie that it took in 2018, 14 years after it landed. It was nicknamed Oppie, and it lasted long enough to have a nickname. This was cool. The reason it lasted 14 years, almost 14 years and a month. Its planned mission was only 3 months. So it did pretty good. It traveled about 28 miles during its time, and it did a real good. If we had had Spirit also working that long, it would have been really cool. But Mars Reconnaissance Orbiter, it was also launched by the United States. It has been in orbit since 2026, and the mission was recently extended. They figured out they had enough fuel into the 2020s. They're not sure when it's going to run out, but they're going to keep doing it. Curiosity was launched by the U.S. It landed in 2021. It landed at Gale Crater, and it has traveled only 15 miles so far, but it's still working. Not going on 9 years later. And this was a selfie of the Curiosity rover from 2015. And it provided the first live video, just like this, from Mars in 2012 for a conference call with, and provided the video while NASA engineers and astronomers and other people and planetary scientists provided the commentary on what it was doing and how it had been working overall on the mission. The design of this, it's lasted so long, this is cool. The design serves as the basis for tomorrow's Perseverance lander rover. And spare parts from Curiosity that were left over from tests and construction, the spare parts have been used on Perseverance. And this was a selfie taken on November 12th last year. It is still working. Curiosity is still in operation. It's still wandering around on the surface. This is a spot called Marianning. It was dubbed that because it kind of looks like a place that there might be fossils. And Mary Anning was a famous fossilist near Lyme Regis in Great Britain, England. If you want to follow Curiosity Rover, they're on Twitter, even if I spell it right. I didn't spell Twitter right, but they're on Twitter at Mars Curiosity, and you can follow along on the mission as it updates. MAVEN, the Mars Atmospheric and Volatile Evolution Orbiter, has been in orbit since 2014. It is fueled until 2030, and it is studying how the solar wind affects the Martian atmosphere. And they're looking to see, in part, how the atmosphere of Mars is going away. It's being taken away by the solar wind. Ours is also, but we're producing through volcanic action more atmosphere. Mars has been dead for at least a few million years. No volcanoes have erupted in a few million years. So its atmosphere is not being replenished and is thinning. They're trying to look at how and why it's thinning and how much, how fast it's thinning. Mars Orbiter mission. It is still operational. It was launched by India in 2014. Mangalyaan is the Indian name for it. It is at a slightly wider orbit than most of the other orbiters on Mars. It's able to take planet-size, whole planet photographs, and it's examining the upper atmosphere and working with that, as well as providing some context. A lot of these orbiters are down in the mud, so to speak. They're down near really close to the atmosphere, and they're only take pictures of a little part of the planet. They're not able to see the bigger picture, which is sometimes needed. They have to put all these little pictures together. The Mars Orbiter mission, also called MOM, can take pictures at a wider angle, and this is also useful. Nobody else was doing it, so India said, hey, we can do that. The ExoMars Trace Gas Orbiter, launched by European Space Agency in Russia, it's been working since 2016. Don't know its life expectancy. It had a rover or lander associated with it, but the lander crashed when it was released. The lander didn't make it, but the orbiter is still in use, and so they've repurposed it, and it will be used with a new lander that will be launched next year. And the rover they launched was called Schiaparelli in 2016, and the InSight lander, more recent yet, launched again by the United States. It landed in 2018, and its mission is geologic studies. It has been extended to at least next year. See what happens with that, see if it works. It has a heat probe and a seismic detector attached to it. I've labeled them there on the picture. The heat probe has just been turned off. It didn't work. It was supposed to burrow into the soil and go at least a couple of feet down and hopefully longer, and was supposed to take temperature measurements to see how fast the heat from the mantle is coming through the crust and how fast the planet is cooling off. Didn't work. It got about a foot down and never got any lower than that. The rock, there's apparently a rock in front of it, or the mud is just too thick. I'm not sure. They probably are, but they just canceled that part of the mission. The other part, the little cup there on the right, is a seismic detector. And the seismic detector is recording Marsquakes, helping to define the interior of Mars, like the study of earthquakes here has helped to define the interior structure of Earth. The largest measured Marsquake is measured 4.5, and they can be common. They know that now. They can be very common. For the first about 9 months of the mission, they didn't detect any Marsquakes. It was really windy on Mars, and they got a lot of wind buckling the earth, rocking the earth near the lander, but they didn't get any real Marsquakes, and they couldn't understand why. And then the wind died down a little bit, and suddenly they're seeing Marsquakes all over the place. So they now know that they can be common. They apparently landed in the middle of a quiet time for Earth movement. They're probably due to the planet cooling. And if you've ever listened to the ticking of an engine as it cools, that's what is probably causing the Marsquakes. That little ticking as the planet shrinks a little as it cools, like an engine, like the metal in an engine is shrinking just a little bit, and that's ticking sound comes from that. They have detected P and S waves, like here on Earth, but they have not detected any surface waves. For some reason, Marsquakes don't move along the surface of the planet, Marsquake. So the surface waves are the ones that go up and down, like the ocean waves, and they are the ones that cause most of the damage as your buildings go up and down, sometimes corner to corner like this, and so they're the ones that tear things apart. So Marsquakes seem to be potentially less dangerous to a structure. I'm not sure. They'll have to do more study. They may just discover surface waves tonight. They have found, because based on this and other studies they've done, and based on a lot of the geology that has come from this, they have found that it has a thin crust. The planet has a thin crust, about 30 miles thick. The mantle is about 1,100 miles thick, and it is molten, but it is fairly cool for a molten mantle, and it has a molten iron core. It doesn't appear that there's solid there. Sources differ, but the newest information appears to be that the iron core in the center of the planet is molten. Unlike ours, which is solid, more solid at least, it does not rotate inside the mantle. And so, unlike Earth, because that rotation on Earth, in Earth's core, causes the magnetic field, that shields us from the solar wind and from gamma rays and a bunch of other stuff. This does not. All right, Insight Lander will be listening for the seismic signature from Perseverance tomorrow. And Hope, launched by the United Arab Emirates, in orbit last Tuesday. And this is Hope's first image, if you haven't seen it yet. This is the first image of Mars. They are at a similar orbit to the Indian orbiter, and they put it in a wide orbit so they could watch the whole of a hemisphere and watch the climate and the planet's weather. Instead of looking at these little dots, they can see clouds move across large spaces and dust storms moving across in large scale. And just for orientation, there's the North Pole. There's Mons Olympus, right on the terminator there, barely there. And those are the most prominent features, I think, on Mars. The three volcanoes that look like somebody has put their fingers in there, with Mons Olympus as the thumb. And the the Mariana Valley, the Mars Grand Canyon, it runs 4,000 miles across a quarter of the planet. So it's quite an impressive thing. Yeah, our Grand Canyon is grand compared to this. No, but compared to Mons Olympus, Everest is a piker. And just because these are Ulysses Thoris and Biblis Tholis, excuse me. And there are two little craters there. When you see this picture up close, you may see that and think, that's Olympus Mons, like I did. No, those are two much smaller craters. Tianwen. Tianwen-1 launched by China, and it went into orbit Wednesday, 1 week ago. And we have no idea of what its mission lifespan is. This is its first image. It was actually taken on the way to Mars. They turned on the camera early and took this picture just as they were arriving. It was released on Wednesday. I don't know when it was taken. It is the first attempt at Mars in China. It has an orbiter, a lander, and a rover. For a first attempt, that's a lot of stuff. Remember our Mariner 4, it just went by. China's rather ambitious. And it is to study the atmosphere and geology and the surface environment. We don't know a lot about Tianwen, but tried to put together as much as I could. It has the orbiter has camera, subsurface radar, and a mineralogical spectrometer. So us mineralogists should really enjoy the data coming back from that. Has a lander and a rover as well. As I said, this lander and rover will be launched later this year. Some sources say May, some say July. I don't know. We'll find out when they release the information. Their expected lifespan is 3 months, but then one of ours did too, and 14 years later it shut off. So you never know. But the planned mission is 3 months. And the lander and rover have ground penetrating radar and cameras and atmospheric detectors, and that's all I could find out. These are the landings on Mars. We're getting near the end here. These are Mars landings, 14 attempts, 8 have been successful. The blue labels are the ones that will be coming up starting tomorrow. Mars 2020 is Perseverance. And ExoMars is supposed to be launched next year. It's supposed to be launched last year, but it's going to be launched next year. And these are the dates. Now, I don't want you to look at the dates. You can pause it if you want and look at the dates, but the red are all failures. The green are the successes. The blue are, we don't know yet because they haven't landed yet. And these are the launch dates, by the way. Make sure you note that. These are not the landing dates. That's why Perseverance up there in the middle as July 30th of last year. It did not land then. That was when it was launched. It will land tomorrow, hopefully. Tianwen, the lander coming in July or May. We don't know where it's going to land. There are some guesses, but I didn't want to put it on the map because I didn't have a clue. Those that are still working as of tonight, InSight and Curiosity. Curiosity, the rover, InSight, with the seismic detectors. And these are the NASA landing sites that we have, Perseverance being tomorrow. It's just the NASA landings. Everybody else's are gone from the screen. All right, future exploration. Yes, we have a future on Mars. Perseverance lands tomorrow about 1 p.m. Well, starting about 1 p.m. That is changing. Let's see if I have my right information here. There you go. It's scheduled for about 1 to 2 tomorrow. That's when the beginning of the lander is. And so that is that. It has been nicknamed Percy, and I'm not sure who nicknamed it Percy. I've seen a couple of places where it's been nicknamed Percy. If you want to follow it along, they have a Facebook page for it. They also have a Twitter feed. You can also just go to NASA's Mars website. But the NASA Perseverance rover official channel is there. NASA Persevere, what? Yeah, whatever. The Twitter feed is there. Also, there's a unofficial semi-common comedy account. They make light of it, but it's good science and links to the real science as well. But it's a fun one to follow. Ingenuity is landing with Perseverance tomorrow, and its planned flight is next month, and a month from now, just after if you were paying attention, just after our March meeting. And it is going to mostly study flight on Mars, make sure that we can run a drone with an 11-minute plus delay of instructions. And if it's successful, it will navigate for Perseverance. It'll be a help to the land rover. And it's been nicknamed Ginny, and it has an unofficial, like Percy, has an unofficial Twitter feed, which you can see there. Along with Perseverance, 1.2 million names of people will be landing on Mars. They all have boarding passes like this. This is a friend of mine who got in on it. I failed to, but her name is going up there along with 1.2 million other names. And this is her boarding pass. And that's when it's expected to land. And it's got, points aren't frequent flyer points and all sorts of fun stuff. It's just a fun thing to get. Perseverance rover will start at that time, 1:55. It'll start the 7 minutes of terror. This is the landing time where there is no contact and there's nothing NASA can do. Once it starts on that descent, the computer the onboard computer takes over, and the radio goes silent because it's moving at speed, and it's too hot to put out a radio signal. And NASA just hopes that 7 minutes later, there will be a signal from it. If sometimes they never get heard from again. This is the sky crane. What will happen is it'll have a parachute, and then the parachute is attached to the top here, the top vehicle here, and then at some point in the entry, instead of that big balloon thing the Pathfinder had, it's going to drop on cables the lander, and then the lander the idea is that the canopy has these retro rockets. And it will gently put Perseverance down, and the cables will sever, and the canopy will fly away to crash somewhere. And if you're near a Krispy Kreme, this is a possibility tomorrow. They're going to put out the Mars donuts. I just thought this was cool. This is a leaked promo ad. It was under consideration at the time. I don't know if they're actually doing this. I haven't seen any ads here, but we have no Krispy Kremes right here anyway. You might check with your local store just to see. It's circulating on the internet. This is the next mission to land in 2023. It has on it the Rosalind Franklin rover, and this is the prototype of it. It's going to be launched by Europe and Russia, and this is the prototype being tested a couple of years ago. It was planned for earlier. There were issues. I'm not sure what they were exactly, but there were issues, and so it had to be delayed. And then India is sending up another launch, another orbiter for 2024. And these are the other future Mars missions. When this was written, Tianwen was a future issue or a future launch. It's not anymore. Well, the lander is. It's going to land sometime this year. These are landers, excuse me. The Martian moons are going to be explored by Japan during 2 years. A couple more, Europe, Russia. Our next mission here is to launch in 2026, and it will be a lander called Icebreaker. It's going to be an impact impact lander. It's going to be a bunch of little landers, and it's going to throw themselves at the surface and try and drill down just by their landing into the surface and get some subsurface measurements, hopefully without blowing up. This is my ticket for the icebreaker. You can still get them. They're free. Go to NASA. There's your web address. I believe the web address, if it's not, it will be in the description. I'm pretty sure I put all the websites and Twitter things in the description tonight. Martian meteorites are another way we have getting information of Mars. At least 126. The nearest one to us in Arizona is from the Mojave Desert of California. And it's, we don't know exactly where because the rockhound that found it doesn't want the place identified publicly so that other people go there. Curiosity, in doing Martian studies in 2011, confirmed that the makeup of the rocks where it was doing geological sampling is the same as the Martian meteorites. So it was confirmed that they are Martian meteorites, rather than just saying, well, this looks like Mars. This is my piece of Mars. This is from Northwest Africa, 44768. That's my piece right there. And it was originally found in 2006. You can buy them on Amazon and eBay and a couple other places. I can't remember exactly which one I got this from, but you can buy your own piece of Mars. This is the closest I could get to my actual meteorite site. If you look here real close, you can see that little thing in the white circle is my piece of Mars, and this is that's not even 2 inches on the side, and I don't see canals. It was published though, and it does resemble rocks found at the Opportunity landing site. If this is real, I'm not going to give this to ASU and have them test it. I'm just going to pretend that it's real. Now we have in our explorations come up with a good geological map of Mars. This, I did put the link if you want it. It also has a key published, and you can find out the good geology of Mars. This is a comparison of the original map and the USGS map. It was published 2014, I think. And we've got the place names here. And I want to point out Mons Olympus on this map here. This is a good relief map. And those three volcanoes and their relationship to Mons Olympus, they are the Tharsis Montes together. They are the most prominent things on Mars to many people when they look at a map. As you can see, it's not much else is there. But this is the Valles Marineris, and it is 4,000 miles roughly between those two arrows. This is the Argyle Basin. Remember that from way back in the 1870s? It's still there, still with the same name. And this is Hellas. The Hellas Basin, remember Greece from that same map. And Chrysi Planitia, where the Viking landed, Popia Planitia, where Viking 2 landed. And these are three places, the Argyle Basin, Hellas Basin, and the Iridis Planitia. Planitia means plain. Those three places show up on this map. This is Lowell's map overlaying the modern map, and those places I had to split up Lowell's map because it was a different view, the opposite view of the planet. But I had to I've overlaid that, and if you look near the Hellas Basin, there is a little light indent into what is the dark there, and that is the Iridis Basin. Iridis Planitia. And so he got some things, he was seeing real things. He just didn't see the canals. They thought, here's his map, and back to the modern map and lols. European Space Agency put out this. This is one of the best maps of Mars. This is a hiking map. They put out a number of these, and it's a topo map, 1 to 50,000. I think this is really cool because just like you can get a topographical map to do rock hounding or hiking here on Earth, you can now get some from Mars. Doesn't have the whole planet covered, but neither do we. And that's the range of maps. What's happened in the last 200 years. To finish up, I want to use this quote from Ray Bradbury. We are all children of this universe, not just Earth or Mars or this system, but the whole grand fireworks. And if we are interested in Mars at all, it is only because we wonder over our past and worry terribly about our possible future. Thank you. And remember, the landing is at 12. I'm not sure. The land. I got that last one from NASA. So start watching 11:15, or start looking forward to 11:15 or 12:15, and you will start to see not the landing, but the pre-landing information. So, in some of the publicity, you saw that I'm writing a book, or I'm working on a book, and this is that book, The Annotated Mars. I hope it's launching next year. We'll see. And what I'm doing is some of the original sources that I mentioned earlier and some that I have not, I'm annotating them and editing them for a modern audience. Oh, I don't see any comments. I hope there are questions. If you have any, I'll try to answer them. You can put them in the comments of the video. I should have mentioned that a couple of times before, but let's see, I'm going to unshare that and remove that and show up. Big time. All right. I thank you very much for watching. Again, our next presentation is going to be March 17th, a month from today. The third Wednesday is always it, at least through May. We got 3 more of these to go this winter season and non-summer season before it starts turning at 115 degrees here in beautiful southern Arizona. It was 65 today. I hope you're not watching from Texas and getting jealous. All right. So I hope you will come enjoy this show. If you have comments, you can email. You can. There's the. Let's see. There was. Don't just get that email back. penalgeologymuseum.com or penalgeologymuseum@gmail.com.